So, hello, my name is François-Xavier, and I work at Ubisoft on the Snowdrop engine, and that is used for doing this kind of game, so Mario plus Rabbids, Avatar, or the next Star Wars. So today I will talk about the deprecated attribute, and this is a deprecated attribute that is not meant that I am deprecated. So, sorry. So, the deprecated attribute starts in C++ 14, and inside the standard, it's a quite short specification. In fact, it's too long for one slide, but it's less than a page on the standard. There is mostly 4 paragraphs in it. One that gives the intention of the attribute, one that gives where to put it, so you see it on the slide, one that says something about redeclaration of a variable with and without the attribute. I skip this one, and the consequence. The meaningful thing here is the consequence, and it's basically saying implementation should use the deprecated attribute to produce a diagnostic message. Here, implementations are compilers, and the diagnostic message is the warning, the one that nobody cares about. So, it seems pretty simple, and basically everyone say, okay, I just put deprecating and it will work. But do you think it really works like that? We will look a little bit at it. So we will play a little game here. I will show you a piece of code and we'll ask you the question, do you think compilers warn on this situation? Just raise your hand if you think so, and we will see the result. So one of the simplest examples that we can put, foo function that is tagged as deprecated, and a bar function that is calling foo. Do you think that compilers should warn here? Just raise your hand if you think so. So yes, normally everyone should raise his hand, because all compilers, MSVC, GCC, and Clang are properly emitting a warning. But that's really a simple case. Going a little bit further. So same example as before, but now the bar function is tagged as deprecated. Now, do you think that compiler should emit a warning here? There's one. It's less convincing. And you will see that not all compilers agree on this one. MSVC and GCC say, yes, you call foo that is deprecated, it's a warning. Clang kind of seems to say that if you are inside the deprecated function, you don't care about any deprecation that you are using. Maybe discussable, I would say. Another one. This one is a little bit similar with the previous one. You have so you can deprecate a namespace. So I deprecate the namespace ns, create a struct d inside it, and do an alias of d inside d2. Do you think compilers should emit a warning here? No one is raising his hand. And I was almost like you, but GCC say, oh no, D is deprecated. And you are like, yeah, but I am inside the namespace. At first I was like, oh, why is doing that? And maybe there is a reason, in the sense that you might later on restart the namespace ns. You didn't tag it as deprecated, but the standard say, as soon as it has been deprecated once, it will be deprecating forever. So if we split the declaration of the namespace, and we have first the struct d inside the namespace, and after that we redeclare the namespace and we say using d2 equal d, maybe here there is a reason to say d was deprecated. But as before, it's discussable. Another one, and this one are pretty nice. So you have this struct s that has a member variable I that is deprecated. Okay, and we create a variable of this struct. Do you think compilers should warn here? There are some people saying yeah, and GCC say yes. The other one no. But GCC doesn't say yes one time, but twice. Don't know why, but like that. So, okay, that was simple. But if we do that, now I use an aggregate initialization to initialize I inside this structure. Do you think that compiler should emit a warning? I'm pretty sure more people will say yes. And here I don't understand GCC because now it say no, that's fine. Clang say yes, and MSVC say I don't care about that. That's super weird. I don't know why. Maybe it's just bug. It's difficult to understand. What?
It should be a compile error. Like, why would you say that?
Yeah. Even more than that, if you use designated initializer, so nothing is implicit here. You have said the name I. Only Clang will say you are using something deprecated. Other thing funny. So you have this struct S with a user-defined destructor and a deprecated string S inside it. There is no variable declaration, nothing at all after that. Do you think the compiler should warn here? No one thinks that? Oh, MSVC and GCC are like, no, inside this destructor, we are using the string that is kind of destroyed, so it's a, yeah. And GCC, as always, twice, two warnings for that. What is strange is if you don't declare the user-defined destructor, it will say, no one will say a warning. And if instead of stud strings, I have trivially destructible type, it will say okay, even if I have the user-defined destructor. It's kind of weird. Another one, which seems to be a bug for me, but you have this struct D that is deprecated. We do a foo function that has an auto return type and just return a default constructed D. Do you think compiler should warn? Yes.
No.
No. Clang yes. GCC and MSVC are just saying no. Don't know why. Seems to be some bug. Because if you put the D type as a return type, every compiler say, yes, you are using D that is deprecated. Like, okay. Some fun things. So we have this, so you can put deprecated on using, and using, as you know, can be templated. So here we just do an alias on stud vector T from using. So to have this short name for a vector, and we create a vector of int v. Do you think compiler should emit a warning? Yes. I would assume most people say yes. And Clang say no. I don't know why. This is, I think, the worst bug for Clang. Most of the time, Clang is quite good. Here, it just missed this one, which is kind of bad. Another one, because we did some little template, but not enough. We are doing C++. We have this struct S, which is templated with two template parameters, and we do a partial specialization of this class. So the standard say you can put the deprecated attribute on a specialization. So I would assume you can do that. And you declare a variable of the type of the partial specialization. Do you think compilers should raise a warning here? Yes. No one is doing it. It's like, we don't care. I don't know if they read the specification by the letter and say, no, there is never said partial specialization, so we shouldn't do that, or they just miss it. I don't know. Another one which is funny and kind of arguable is like we create this struct S that is templated and deprecated. And now we do a specialization which is not deprecated. Do you think when we create a variable of this specialization, should we emit a warning or not? Some people say yes. I don't know, and not all compilers agree on that. GCC say yes at both sites. So whenever S is mentioned, it will say yes, warning. GCC and MSVC, Clang and MSVC say okay. And that's all for today. So is deprecated that bad? Not really. I show you a lot of weird cases. There is some weird bug, and I think I should report all of them to all compilers. But in our case, we are trying to put some API as deprecated and remove them along the way. We are using mostly Clang to check that. So it's not that painful for us. But yeah, you need to know that it's not perfect. And I need to open bug reports. Yes?
I have I think one of the reasons why it's this way is that all standard attributes are ignorable by implementations.
Yeah.
So technically there's a specification, but the implementer can actually decide in all situations to just don't do anything.
Exactly. And if you look at the consequence here, there is a should.
Yeah.
There is no obligation at all. That's that's the point. And I don't think the specification should really change to accommodate this. I think it's mostly bug report to compiler saying, okay, maybe your user want to have a warning here, but yes, you cannot force them. And the standard is not here to force them.
Is the standard still saying what you should say if you want to enforce it, or it's like implementation defined, whatever?
It just says that, mostly. There is a little bit more with after that, but not much more than that.
Okay, so it's like free for all.
Yeah. And so after that, I think it's pizza time. You're welcome.
Some lightning talk.
Ah, no pizza, sorry.
Je te donne le micro. It's going to be very short. I'm not going to prevent the pizza. It's actually just showing a small code snippet. It's an ongoing project, but it has fun implications. It's basically, well, I'm sorry, can't find a way to put it. Maybe here. It's going to be difficult. Sorry.
Put it on the table.
Yeah, I'm putting it up the table. Basically, I act in a C++ feature, so a language feature. So okay, I'm just on this screen, and it's just a small showcase. Yeah, we'll duplicate. Yeah, if I put. Basically, here you have an example where it's you have the feature is already working, and you can actually see it on the first function, the auto test function.
Can you zoom a bit?
Yeah, of course. Oh wow, a bit too much. I'm using like a Clang extension, so it's LLVM that's doing the auto deduction, so it already finds the return type of the function, and basically the custom auto return variable, we don't know really what it is right now from the glance, basically implements a custom resolution of auto conflict. So your function is supposed to return once. If it returns in an auto returning function, if it returns two types, usually just compile error. Basically here you give this this tool lambda function. You give specify some template parameters. So here it's args. Then you use these template parameters inside as the first argument of your function, and basically this will be your return. And inside you will actually create the args. So for example, here I equal ret with 314 and 42, and by magic the compiler actually deduced that my return variable, the variant, is actually a variant double int. If I suddenly add here like if false and ret equals something like this, we can overglance here. We just see the const char étoile just added to the function method. And the way it's implemented is basically using a weird trick that was created like a few years ago, which is stateful template metaprogramming, which is basically you use French injection and ADL lookup, and basically you hack in mutating the state of your transpilation unit and actually looking which state you are, so you can do conditionals, so you can start implementing containers and things like this at compile time. And so basically here you have like we first instantiate the function that's given in the lambda once with a mock type that will iterate and receive the value. Each time ret is being equaled, basically there's like a conversion operator that's being called, and it takes the type and add it into like a type set, a compile time type set, and at the end it actually just returns once using the actual phenotype that you want, and so you don't have any side effect on the runtime. It's just full compile time. And you have some other example, for example here, instead of using like directly the type, I have some lazy object that has like a novel loaded operator like this, which means that the object will be only created at return, but each return inside will be consistent. And for example, I can do something a bit more complicated like this, where you specify that you want to ignore monostate because you want your variable to be potentially default initializable. And the variable that you want to return is like a vector or variant of monostate of args, something like this, and you can just push back inside the different values. And if we overglance here, we see that, for example, we have an std vector of variant monoint double, etc., which is like a funny use case. And the main application would be something like, for example, when you're doing parsing and doing basically this kind of things. So yeah, that was all. Thank you.